All right, this video is section 5.3, factoring trinomials when a is not equal to 1. Practice examples. We're going to do some factoring. The first question says 2x squared plus 7x plus 3. Now, it's always preferable to look for a GCF first so that we can get this 2 off if it's common, but in this question and in most of these questions on this page, the 2 is not common, so we cannot factor using our standard trinomial factoring method. Instead, and I'm going to use the square root method, which is exampled in your book, but there are lots of other methods to do this. I'm going to use a square root method, which says that you take this first coefficient, the 2, and you multiply it times the first term and the last term. And that changes the expression up a little bit. The middle term does not change. And then we square root the first term. So the square root of 4x squared is 2x, and that's going to go here and here. We do the same thing we did with the signs with standard trinomials. The first sign comes down, and then we multiply the signs to get the second one. So positive times positive makes positive. And now we look for two numbers that multiply to make 6, but add to make 7. Because they're the same signs, they will add to make 7. So the two numbers that multiply to make 6 and add to make 7. And sometimes it's a little bit harder than this, but you can always make a list over here of the numbers that multiply to make 6. The two that multiply to make 6 and add to make 7 are 6 and 1. Now with this method, because we changed the expression up here by multiply, we have to get that multiply back off by using divide. So we're going to divide each of these binomials by whatever the GCF of each binomial is. So when I look at these two terms, what's common here? The GCF of 2x and 6 is 2. So I'm going to multiply divide both of these terms by 2. There is no GCF here, but of course, 1 is always common. These two numbers that you're dividing off should always multiply to make the number that you started with, which is 2 at the top. So divide both of these terms by 2, and we end up with x plus 3 times 2x plus 1. Because when you divide these by 1, they don't change. But divide both of these terms by 2, you get x plus 3. And those are your factors. So let's move on to number 2. We're going to factor 6x squared plus 7x plus 2. And again, if we can get this 6 off with a GCF, we will, but it's not common. So instead, we'll take that 6 and we'll multiply it times the first term and the last term. And that gives us 36x squared plus 7x plus 12. And then we square root the first term. The square root of 36x squared is 6x. So 6x times 6x. The first sign comes down, and then we do positive times positive makes positive. So these are both going to be plus signs. And now we're looking for two numbers that multiply to make 12, but add to make 7. And again, like I said before, you can make a list over here to the side if you need to find two numbers that multiply to make 12 and add to make 7, and that will be 4 and 3. You always write the biggest one first. Then you divide each of those binomials by whatever their GCF is. What's the GCF of these two terms? 2. And the GCF of these two terms is 3. These two numbers multiply to make the number you started with, which on this question is 6. So, of course, 2 times 3 makes 6. So divide both of these terms by 2. We get 3x plus 2. Divide both of these terms by 3. We get 2x plus 1. And those are your factors. Now, of course, you can always check by doing double distribute or FOIL, and you should get this original expression back. All right? So that's the method we're going to use all the way down these 2 pages. Again, can I get the 8 off with a GCF? No, it's not common, so I'm going to multiply the front term and the end term by 8. So that gives me 64x squared plus 10x minus 24. And then I square root the first term. The square root of 64x squared is 8x, so 8x times 8x. The first sign comes down, and then multiply positive times negative makes negative. So we'll have a plus and a minus here. Again, the first sign comes down, so that's a plus. And then positive times negative makes a negative, and that's the second sign. Now, since these two signs are different, The term in the middle is a subtract. So we're looking for two numbers that multiply to make 24, but subtract to make 10, not add, because these two signs are different. So again, we can make a list off to the side of the numbers that multiply to make 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which ones subtract to make 10? All right, 4 and 6 add to make 10, but that will only work if these signs are the same. So we're going to have to go with 2 and 12 because those are the ones that subtract to make 10. Write the biggest one first, so it's going to be 12 and 2 like this. And then divide by whatever the GCF is. So the GCF of these two terms is 4. They're both divisible by 4. And the GCF of these two terms is 2. And again, these multiply to make the 8 that we started with up here. 4 times 2 is 8. So we're going to divide both of these terms by 4. We get 2x plus 3. And divide both of these terms by 2. We get 4x minus 1. Check by using multiply. You guys can pause the video, do some checking, and then restart the video and move on. Number 4, 6x squared minus x minus 12. Is the 6 a GCF? No. So we're going to have to deal with it using a different method. We're using the square root method, or in some places this is called the Colombian method. This becomes 36x squared minus x minus 72. 6 times 12 is 72. And then we square root the first term. The square root of 36x squared is 6x. Bring the first sign down, and then multiply the signs. Negative times negative makes positive. So the first sign will be negative, the second one positive. And again, they're different signs, so we're subtracting to get this 1 in the middle. So factors of 72 that subtract to make 1. You can make a little list out here if you want. I happen to know that this is 9 times 8. If you know your multiplication facts, this is not too hard. If you don't, you're going to need to make a list. All right, the next step is the divide. So divide by the GCF of these two terms. The GCF of 6x and 9 is 3. The GCF of 6x and 8 is 2. And these two multiply to make a 6. You should always do this little check, because if you get the wrong GCFs here, they won't multiply to make 6. And then you know that you've either got something wrong here or you got something wrong here. So these two numbers should always multiply to make the number you started with. Divide these both by 3. We get 2x minus 3. Divide these both by 2. We get 3x plus 4. Check by doing double distribute. All right, number 5. 4x squared plus x minus 15. Is the 4 common? Well, it is here, but the 4 doesn't go into 15, so we can't get it off with a GCF. So we multiply the first and the last terms both by 4. 16x squared plus 4x minus 60. And then we square root the first term. The square root of 16x squared is 4x, so 4x times 4x. The first sign comes down, so this will be a plus. Positive times negative makes negative, so this will be a minus. So again, different signs. So two numbers that multiply to make 60, but subtract to make 4. Okay, do we need to make a list? What multiplies to make 60? 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. So, which two numbers multiply to make 60 but subtract to make 4? And they are subtracting because these are different signs here. So, looking down here, it looks like it must be 6 and 10. Write the biggest one first because we need a positive 4. So if you look now what you did, you have positive 10 plus negative 6 makes positive 4. Positive 10 times negative 6 makes negative 60. And then we divide by the GCF. The GCF of these two terms is 2. The GCF of these two terms is also 2. These multiply to make the 4 we started with. So we're going to divide both of these terms by 2. That makes 2x plus 5. And we're going to divide both of these terms by 2 also. and that will make 2x minus 3. And you check them by multiplying. All right, number 6. 5x squared minus 17x plus 6. The 5 is not common, so we're going to have to do this square root method, or some other method if you know it. Your book outlines 2 other methods if you want to use them. Okay, now we square root the first term. Square root of 25x squared is 5x. This minus sign is going to come down. Negative times positive makes negative, so we will have 2 negative signs here. So now we're looking for factors of 30 that add to make 17, and they're adding because these are the same sign. So what multiplies to make 17 and adds to multiplies to make 30 and adds to make 17, and that would be 15 times 2. Now we divide. What's the GCF of these 2 terms? That would be 5. And the GCF of these 2 terms, well, they don't have anything in common, so we're going to leave it as a 1, which is fine. 5 times 1 makes 5, so we're good. Divide both of these by 5. We get x minus 3. Divide both of these by 1. We get 5x minus 2. Okay, so this is the second page of factoring trinomials that have a is not equal to 1. We're going to start here on number 7. 25x squared plus 21x plus 4 minus 4. Okay, the 25 is not common, so we're going to start by multiplying the first term and the last term, both times 25. Well, 25 times 25 is 125. I'm sorry, it's 625 x squared. That was really sloppy. There we go. Plus 21x minus, well, 25 times 4 is 100. Then we square root the first term. Now, you might not know what the square root of 625 is, but you just did it back here. What number times itself makes 625? Well, that was the 25, wasn't it? So this is going to be 25x times 25x. The first sign comes down, so this will be a plus. Positive times negative makes negative, so this will be a minus. So we have plus and minus. So 2 numbers that multiply to make 100, but subtract to make 21. Because they're different signs, they subtract to make 21. You might need to make a list here. Those 2 numbers turn out to be 25 times 4. And now we're going to divide by the GCF. The GCF of 25 and 25 is 25. The GCF of 25 and 4 is only 1. They're not divisible by any other numbers. And these 2 GCFs multiply to make the 25 we started with. So divide these both by 25. You get x plus 1. Divide these both by 1. You get 25x minus 4. All right, on number 8, 12x squared minus 25x plus 12. The 12 is not common, so we're going to use the square root method again. Multiply the front and the end term both by 12. So 144x squared minus 25x plus 144. Then square root the first term. The square root of 144x squared is 12x, so we're going to have 12x times 12x. The negative sign will come down, so we'll have a negative here. Negative times positive makes negative, so we will have 2 negatives. So we're looking for 2 numbers that multiply to make 144, but add to make 25. If you need to make a list off to the side, it's perfectly fine. As you make your list down, you should come to the end, 9 times 16. And we're going to write the biggest one first. 9 times 16 is 144. 9 plus 16 is 25. So when we add negative 16, negative 9, we get negative 25. When we multiply them, we get positive 144. And now we're going to divide. What's the GCF of 12x and 16? That would be 4. And the GCF of 12x and 9 would be 3. And they multiply to make the 12 we started with up here. So divide these both by 4. You get 3x minus 4. Divide these both by 3. You get 4x minus 3. And you check them by multiplying. All right, 20x squared minus 31x minus 7. The 20 is not common, so we're going to start with a multiply the first term and the last term by 20. 20 times 20 is 400, so we have 400x squared minus 31x minus 7 times 20 is 140. Square root the first term. The square root of 400x squared is the same thing that you multiplied to get the 400, 20x. The first sign comes down. Multiply the two signs to get the second one. Negative times negative makes positive. Okay? So we're looking for two numbers that multiply to make 140, but subtract to make 31. So if you need to make a list over to the side, that's fine. I started with 1 times 140, 2 times 70, 3 doesn't go into 140, 4 times 35. And those are the numbers I ended up with because I can subtract those to get the 31. So we're going to write the biggest one first. So we'll have a 35 times a 4. And we're going to divide by whatever the GCF is here. The GCF of 20 and 35 is 5, so we're going to divide by 5. The GCF of 20 and 4 is 4, so we'll divide by 4. And they do multiply to give you the 20 that you started with up here. So 5 times 4 is 20. Divide these both by 5, divide these both by 4. You get 4x minus 7, 5x plus 1. All right, number 10, 2x squared plus 3x plus 9. I would love it if this 2 was common, but I can't get it off with a GCF because it's not common. So I'm going to multiply the first term and the last term by 2. So that gives me 4x squared plus 3x plus 18. Square root the first term, so 2x times 2x. The first sign comes down. Multiply the two signs for the second one. Positive times positive is positive, so we have same signs. So we're looking for factors of 18 that add to make 3. Wow, that's interesting. Are there any factors of 18 that will add to make 3? Well, when we start listing the factors of 18, we have 1 times 18, 2 times 9, 3 times 6. Those are all the factors of 18. But because we have the same signs here, they have to add to make 3. None of these pairs of factors are going to add to make 3. They can subtract to make 3, but that would only happen if these signs were different. So I'm checking my signs. The first sign comes down. Positive times positive makes positive. So they definitely have to add in the middle because they're the same sign. The 6 and the 3 will only work if these are different signs. They're not different signs. None of these other pairs will add to make 3. So there are no factors that will match here to give us this original expression. So this expression is prime. In other words, it does not factor. If you're working in our online homework system of iMath AS, it would be DNE. That's not official math lingo, that's programming lingo if you're working in that software. So number 10 is prime. It doesn't factor. Number 11, 2x cubed plus 4x squared minus 30x. Now you might notice right off the bat that we have more variables here than we did in the previous examples. I'm just going to scroll up here a little bit. When you look at this one, we have an x squared term, an x term, and a constant term that has no variable. This is the standard form of a trinomial that factors to two binomials. When you look at this one and you see that you've got more variables, it's not going to factor in standard form, so you have to take these variables into account. But of course, the first thing we're always looking for is this 2 common? Can I get it off with a GCF? And it does turn out in this expression, the 2 is common, but also this x is common. So we definitely have a big GCF here of 2x. And we can divide all these terms by 2x for starters. So when we divide this by 2x, every term, because that's a GCF, we get x squared plus 2x minus 15. And now this resulting trinomial is a standard trinomial. We will not even have to use the square root method on this because the coefficient here is 1, the lead coefficient. So our GCF of 2x comes down, and we're going to factor this standard trinomial as x times x. First sign comes down. Positive times negative makes negative. So looking for two numbers that multiply to make 15, but subtract to make 2, and that would be 5 and 3. So don't make it harder than it is. Always look for this GCF first to see what kind of trinomial you're ending with. On number 12, same kind of thing is going to happen, especially since I noticed this negative sign right here. But the 3 is also common. All of these terms can be divided by 3. So I'm going to factor off the negative 3 as the first step. Divide all these terms by negative 3. And we get x squared minus 3x minus 18. 54 divided by 3 is 18. And you'll notice that because we divided by a negative, the signs all changed. Negative divided by negative makes positive. Positive divided by negative makes negative. Positive divided by negative makes negative. So these signs changed. This GCF is going to stay here. But again, we're ending with a standard trinomial here, so we don't have to do the square root method on this. We can just go right to our trinomial factoring here. X times x, the first sign comes down. Negative times negative makes positive. So we're looking for two numbers that multiply to make 18, but subtract to make 3 because these are different signs. And I think we had that up above. Let's see. Here in our list of numbers that multiply to make 18 that subtract to make 3, that would be the 6 and the 3, wouldn't it? So we can put 6 and 3 here. So negative 3 times x minus 6 times x plus 3.